Hey, stuffers. Why did the ocean floor break up with the surface? Because it needed space, and also it was deeply stressed out. Alex here, and welcome back to Stuff with Alex. We live on a blue planet, right? Looks peaceful from space. Looks like a vacation brochure. But 66% of that blue is a crushing, lightless void, an environment so hostile and inaccessible that it is, statistically, more alien than Mars. For millennia, sailors relied on ancient myths, painting charts with terrifying beasts, the Kraken, the Leviathan, the stuff of nightmares and bad tattoos, to explain the deep. Then, science finally got off its butt and started mapping the abyss. We traded the ancient myths for modern paranoia. We found life systems powered not by the sun, but by pure chemistry, hanging out in eternal darkness at temperatures hovering just above freezing. We realized the deep sea was the engine room of the planet, where tectonic plates clash and raw chemical energy fuels life. It's wild! Then, in 1997, sophisticated hydrophones, the ears of our secret military monitoring systems, recorded something absolutely monstrous in the remote Pacific. A sound dubbed the Bloop. This signal was louder than any creature known to science. It echoed across thousands of kilometers. Was it the Cthulhu we always feared? Was the Kraken finally asking for a word with humanity? At the very same time we were listening for deep-sea titans, others were convinced the ocean held military secrets far darker than any monster. They spoke of lost technology, hidden Nazi bases in Antarctica, protected by U-boats and strange forces, fueling a conspiracy theory that still thrives today. The question isn't whether the deep is mysterious, it's whether the deepest mysteries are biological, geological, or deeply, annoyingly human. This episode will explore how cutting-edge technology and recent scientific breakthroughs are rapidly replacing our ancient fears of the deep with an even more complex reality, challenging our understanding of life, history, and Earth's geologic engine. Before the age of high-tech submersibles, the deep ocean was genuinely unknowable. Scientific oceanography began in earnest in the 1870s with the massive 4-year HMS Challenger expedition. That expedition was foundational, conducting the first truly comprehensive global survey using simple tools like dredges and trawls to collect deep-sea samples. What they proved was revolutionary for the time. The abyss was not a lifeless, azoic void, but a place teeming with complex, if bizarre, biological communities. Then, science finally managed to put a human face on the deep with the bathysphere in the 1930s. This was basically a thick, non-propelled steel ball used by William Beebe and Otis Barton. They managed to get views of the deep sea, achieving depths just shy of 1,000 meters. That's impressive, but to put it in perspective, 1,000 meters is still basically the ocean's attic. We had barely scratched the twilight zone. The true frontier, the final frontier on Earth, was the trenches, the Hadal zone. The breakthrough concept came from Swiss physicist Auguste Piccard, who conceived of the bathysphere. World War II unfortunately delayed his work until 1945, but the concept, a sort of underwater blimp that used buoyant gasoline rather than air to offset the weight of a heavy steel observation sphere, was the key. Construction finally began in Trieste, Italy, resulting in the famous Trieste. This technology immediately proved its immense dual-purpose significance. After initial operations in the Mediterranean, the U.S. Navy acquired the Trieste in August 1958. This adoption by the Navy is critical. It immediately established that deep-sea technology operates under a dual mandate: science and strategy. The Navy then fitted the craft with a stronger sphere built by Germany's Krupp Iron Works, because if you're going to challenge 11 kilometers of ocean, you need German engineering, and launched Project Nekton near Guam. On January 23, 1960, the Trieste made history. Lieutenant Don Walsh, USN, and Jacques Piccard, August's son, descended nearly 7 miles to the Challenger Deep in the Mariana Trench. That's the deepest known point of the Earth's oceans, roughly 11 kilometers deep. It was, quite literally, the equivalent of landing on the moon, but underwater. It took 5 grueling hours to descend, and the immense pressure famously cracked the exterior viewing port, though the interior sphere held tight, thankfully. This record-setting dive, financed and managed by the military, demonstrated the technological viability of reaching the deepest parts of the planet. Just 3 years later, this strategic value was proven. In April 1963, the nuclear submarine Thresher SSN 593 was lost off the Massachusetts coast. The Trieste was transported across the country to Boston, and after numerous dives, it successfully located debris, including the submarine's sail, confirming the loss. The Navy Unit Commendation awarded to the Trieste and its commander for this search seals the narrative. The deep sea frontier is inherently intertwined with high-level, classified geopolitics. The secrecy surrounding the abyss isn't primarily about protecting ancient alien portals. It's about protecting decades of highly classified sonar data, submarine routes, and the locations of lost nuclear infrastructure. This heavy military involvement, necessitated by the sheer technological challenge, explains why the deep sea remains such a mysterious and politically charged environment for decades, allowing non-scientific theories to flourish in the ensuing knowledge gap. If the 1960s were the age of seeing the deep, the 1990s were the age of listening to it. And what we heard was terrifying. In 1997, the NOAA Vents program, which uses hydrophones designed to monitor underwater volcanoes and detect secret military activity, recorded something truly anomalous. It was a powerful, ultra-low-frequency sound originating from the remote southern Pacific, near the equivalent of the Bermuda Triangle for deep-sea acoustics. Scientists named it the Bloop. The Bloop's characteristics immediately generated sensational theories. Its amplitude, its sheer volume, was far greater than any recorded biological noise, and its range exceeded 5,000 kilometers. If it was biological, it had to be a mega animal, something far bigger and louder than anything currently in the marine census. The sheer power of the noise sparked the wildest speculations, including the inevitable comparisons: H.P. Lovecraft's cosmic horror, Cthulhu, a sleeping entity waiting beneath the waves. The mystery endured for years, feeding internet forums and cryptid hunters. But the NOAA scientists were patient. Their PEML acoustics program is dedicated to acquiring long-term data sets of the global ocean acoustics environment, specifically to identify impacts from both human and natural processes. They needed to find a natural explanation large enough to account for the signal's immense amplitude and range. The resolution finally came years later, through the diligent tracking of massive acryogenic signals. NOAA scientists discovered that the sound emanated from a phenomenon called an icequake. Specifically, the sound was produced by an iceberg cracking and breaking away from an Antarctic glacier. This discovery reveals a critical truth about the deep ocean. It is a deceptively efficient medium for sound. The ocean's deep sound channels, like the SOFAR channel, efficiently propagate acoustic energy across entire ocean basins. A sound that appears impossibly large and close might in fact be a common physical process occurring thousands of miles away, amplified by the water itself. This discovery moves our focus away from simply assuming an acoustic anomaly must be a monster and toward analyzing the massive scale of geophysical processes that surround us. The ocean is not silent. It is a resonant chamber amplifying the sound of continental dynamics. Further tracking, notably of iceberg A53A as it disintegrated near South Georgia Island in the early 2000s, confirmed that large icequakes share similar spectrograms with the Bloop. The scale of the ice fracturing is what generates the necessary power. The final twist? The mystery that once fueled cryptid hunters is now documented evidence of anthropogenic climate impact. Scientists note that with global warming, more and more ice quakes occur annually, breaking off glaciers and cracking vast ice structures. The acoustic monitoring systems that track the Bloop are now inadvertently providing one of the clearest, most undeniable signals of the planet's accelerating glacial disintegration. The Bloop was a warning siren, not from Cthulhu, but from Earth itself. Drop your wildest non-dangerous theory in the comments. If you heard the Bloop in 1997, what would you have thought it was? While the abyssal plain, 4,000 to 6,000 meters, is deep, the absolute rock bottom of the ocean is the Hadal zone, named after Hades, the Greek god of the underworld. This zone extends from 6,000 to 11,000 meters and exists only in deep ocean trenches, which are typically formed where one tectonic plate is subducted beneath another. These trenches are long, narrow submarine canyons. Combined across all oceans, they cover an area about the size of Australia. The conditions in the Hadal zone are defined by extremes: complete darkness, no solar light, temperatures that hover just above freezing, and immense pressure, up to 1,100 times the surface pressure. It's an environment that should, by all rights, be sterile, yet it is teeming with life. Hadal ecosystems survive not on sunlight, but on chemistry. Some organisms rely on organic marine snow, falling from the upper layers of the ocean. Far more fascinating are the creatures that rely on chemosynthesis, chemical energy derived from hydrothermal seeps and cold seeps along the ocean floor. This independence from the sun is one of the most compelling arguments for the possibility of extraterrestrial life in subsurface oceans on distant moons. Studying these deep-sea systems is directly advancing knowledge that will be used when exploring oceans beyond Earth, such as those believed to exist on the moons of Jupiter and Saturn. Life here requires intense physiological and biochemical adaptation. One remarkable example is the Hadal leporides, or snailfish. In shallow-living fish, the enzymes necessary for life are usually inhibited by high pressure, which is why most surface species can't survive the deep. Hadal leporides, however, exhibit high volumes of gelatinous tissues and watery muscles to maintain buoyancy under immense pressure without relying on a gas bladder. Their bodies are literally tuned to the pressure. The Hadal zone also exhibits a fascinating ecological paradox concerning size. Because the trenches are isolated pockets, they have high levels of endemism, species found nowhere else. They also display extreme variations in size. There is notable gigantism in certain crustaceans, such as amphipods, mysids, and isopods. Conversely, there is dwarfism in smaller organisms like nematodes and copepods. This variation demonstrates that the trenches function as isolated deep-sea islands where evolution proceeds along separate, pressurized lines, confirming their ecological uniqueness. As of 2020, over 400 species are known from these Hadal ecosystems. The sheer scale of adaptation is a profoundly humbling scientific realization. The fact that life finds a way to not just survive, but to thrive, developing specialized structures, chemistry, and sizes in the most extreme environment on Earth fundamentally expands our understanding of life's resilience. The deep ocean does not abide by our rules. If the deep sea was the Wild West for exploration in 1960, it is now the Wild West for taxonomy. We are currently in a period of intense discovery, largely driven by global initiatives like Ocean Census. Scientists are racing to catalog the planet's deepest biodiversity using modern tools, and the results are utterly absurd in the best way possible. Just in the past few years, the discoveries have accelerated exponentially. Over 850 new marine species were recently announced by Ocean Census, encompassing dozens of taxonomic groups. These aren't just slugs and algae. They include new species of shark, sea butterfly, mud dragon, bamboo coral, water bear. Yes, a water bear. Octocoral, sponge, shrimp, crab, and squat lobster. This massive influx of data is essential for shaping global strategies for conservation, climate resilience, and natural resource management. The technology driving this is finally solving the scientific bottleneck of traditional classification. Researchers are revolutionizing how species are described using advanced lab techniques to make taxonomy faster and more collaborative. Among the most recent discoveries, 14 new species were unveiled from ocean depths exceeding 6,000 meters, reinforcing just how much life exists in the seemingly lifeless trenches. Two creatures particularly caught the eye, demonstrating the specialized and sometimes comical nature of abyssal evolution. First, meet the carnivorous bivalve, Myanera aliana. This deep-sea mollusk was found at depths between 5,170 and 5,280 meters, setting a new depth record for its genus, approximately 800 meters deeper than any previously known specimen. What's wild is that this specimen was documented entirely through non-invasive micro-CT scanning, a process that generated over 2,000 tomographic images, revealing incredible detail of the animal's soft tissue. The discovery of a highly specialized carnivorous bivalve at this depth dramatically increases the complexity of our understanding of deep-sea food webs. Second, we have the undisputed champion of absurd deep-sea nomenclature, the popcorn-like parasitic isopod Zionia everta. This creature earned its name. The genus name Zia comes from the corn genus because the female displays peculiar, raised structures on her back that genuinely resemble popped corn kernels. This creature, which represents a completely new genus, was found in the Australian intertidal zone, proving that you don't even have to dive 10 kilometers to find something completely ridiculous. The fact that technology allows us to use micro-CT scans to define a species based on 2,000 images means the rate of discovery is about to skyrocket. This rapid acceleration confirms that the deep sea is the planet's largest remaining biological unknown, waiting to be cataloged, if we don't accidentally destroy it first. To discover these new species and understand the planet's geological heart, we rely on increasingly sophisticated mapping tools. While the basic principle remains sonar, technology has advanced far beyond the sound pulses of the 19th century. Today, multi-beam sonar emits multiple sound waves simultaneously, allowing for wider coverage and generating detailed, high-resolution maps of complex underwater topography. These maps are then brought to life by ROVs, remotely operated vehicles, and AUVs, autonomous underwater vehicles. These uncrewed submersibles can dive to extreme depths, capturing centimeter-fine resolution data and collecting samples. Yet despite this technology, vast sections of the ocean floor remain poorly mapped. This leads to profound geological surprises, even in areas previously explored. Geologists recently stumbled upon an ocean anomaly off the coast of Papua New Guinea at the conical seamount, around 1,300 meters beneath the surface. They described the finding as a real surprise. What made it so surprising? This location hosts the world's first documented hybrid magnetic, hydrothermal vent, and hydrocarbon seep system. Imagine a place where two distinct geological processes, fire and ice, energy and oil, occurs simultaneously right next to each other. Hot, mineral-rich hydrothermal fluids, sometimes reaching temperatures of 51 Celsius relative to the ambient 2.6 Celsius, emerge only a few centimeters away from cooler hydrocarbon-rich fluids and gases of thermogenic, heat-driven origin. This combined system, a hot vent bubbling right next to a cool gas seep, had never been documented anywhere else on Earth. The underlying geological mechanism explains this impossible coupling. Beneath the conical seamount, rising magma provides the heat source. This heat doesn't just drive mineral-laden water upward to form traditional hot vents, it also interacts with thick, organic-rich sediment layers present in the local geology. The heat cooks these sediments, generating methane and other hydrocarbons. Both the superheated mineral water and the cooler, methane-heavy gases travel through the same channels to the seafloor, resulting in the simultaneous expulsion of fire and ice. This discovery carries massive implications. Firstly, the fact that this major feature, the Carambusel vent field, went undetected during multiple previous research cruises, even in a region of high scientific interest, demonstrates that the current state of deep-sea mapping is highly incomplete regarding fine-scale critical geological features. Secondly, this hybrid system, which supplies heat, metals, and complex hydrocarbons, organic building blocks, simultaneously creates a uniquely complex ecological niche that supports highly endemic fauna. It is a powerful natural laboratory for life. Understanding how energy sources combine here could provide a crucial new template for understanding how life might originate in chemically diverse, high-energy environments, profoundly altering our models for both Earth's early history and the search for life elsewhere. The deep sea has always been a mirror for human fear. For centuries, folklore provided the cultural explanation for the ocean's violence and unpredictability. Scandinavian sailors feared the Kraken, often depicted as an aggressive, ship-destroying cephalopod. Greek myth had Scylla, and many cultures worldwide have a story about a tentacled beast getting up to no good. Scientists now confirm that the real-life giants, the giant squid and octopus, were the likely inspiration. These animals are rarely seen, possess a body plan unlike anything else, and move in ways that stimulate a primal human fear of the unknown. Their sheer strangeness justified the wildest tales. In modern times, the fear has evolved, shifting from fearing biological monsters to fearing human secrets. Jules Verne standardized the scientific monster narrative in the 19th century, but the 20th and 21st centuries have seen fear migrate into the realm of classified secrets, lost civilizations, and cosmic horror. Modern media reflects this anxiety perfectly. Video games like 2023's Dredge successfully blend the stressful simulation of fishing with the omnipresent dread of Lovecraftian cosmic horror, where unknown entities lurk just beneath the fog. Production company Story Kitchen has already announced that it'll be turning the game into a live-action horror film, proving that demand for this maritime horror is strong. Recent films like Gods of the Deep 2024 take this narrative one step further, centering the plot on a daring mission that uncovers a mysterious opening on the ocean floor, awakening an ancient race of otherworldly beings. This shift demonstrates a fundamental psychological need. Whether it's the ancient Kraken, the cosmic entity Cthulhu, or the deep-sea military-industrial complex, humanity seeks a singular, powerful explanation for the random violence and immense scale of the deep. Conspiracy theories about deep-sea UFO bases or hidden civilizations are simply the modern, classified equivalents of the Kraken myth. They offer a centralized source of control. They are hiding the truth, rather than forcing us to accept impersonal physics, geological forces, and the overwhelming reality of life's biological complexity. The fear has moved from nature to power. This need for a villain is precisely why the most enduring deep-sea conspiracy involves military history and a remote, politically neutralized location, Antarctica. The most popular, enduring, and logistically nonsensical deep-sea conspiracy involves Antarctica, the Nazis, and a shadowy post-war operation. The narrative asserts that a German expedition in 1938-1939 established a massive secret submarine and aircraft base called Neuberchtesgaden in Dronningmodland. This theory claims that after Germany's surrender, U-boats U-530 and U-977 shuttled Hitler, or high-value assets, treasure, and advanced UFO technology to this secret sanctuary beneath the ice. The theory culminates with the claim that the massive 1946-47 U.S. Navy expedition, Operation Highjump, was a secret military mission to locate and destroy this Nazi base. Let's dismantle this with cold, hard facts, which, ironically, is what you find in Antarctica. Fact 1. The German expedition 1938-1939. This was a short voyage, lasting only about a month in the area, focused entirely on staking a claim to protect the German whaling industry. Building a massive hundreds-of-person inland base 250 kilometers from the coast across an uncharted creviced ice shelf would have required vast resources, massive logistical support, and time, none of which the Germans possessed. Furthermore, the claim to New Schwabenland was abandoned in 1945, and there is zero evidence of any further German activity there during WW2. Fact 2. The U-boat surrenders, 1945. Both U-530 and U-977 arrived in Argentina after the war ended. The rumors that they carried Hitler or secret treasure were quickly spread by a Hungarian exile in Argentina named Ladislas Sabo, who published the sensational book Hitler is Alive in 1947. Crucially, the commanders and crews of both U-boats were arrested and interrogated by American, British, and Argentine naval personnel. All interrogations concluded the arrivals were innocuous, and the crews were released. The conspiracy relies on connecting three verifiable historical events with a purely speculative literary bridge that was written for profit. Fact 3. Operation Highjump, 1946-1947. Highjump was a massive public U.S. naval exercise accompanied by 11 journalists that focused on mapping and exploration. Its official report, while confidential in nature, was not secretly classified, and its contents were widely reported in magazines like National Geographic. Most importantly, the operation was centered on the Ross Ice Shelf, on the opposite side of the continent from the alleged Nazi base in Groningen. The operation ended, predictably, because the Antarctic winter began, not because the U.S. fleet was chased off by secret weapons or flying saucers. Fact 4. Debunking the imagery. Modern satellite imagery frequently fuels the conspiracy. For instance, the alleged buried UFO, often cited at specific coordinates in Groningen, is definitively identified as the German Konen Research Station, a modern, non-secret, summer-only scientific facility. The visible features in the satellite photos are merely the components of the research station or its supply train, laid out in a long line at a 90-degree angle to the prevailing wind to prevent deep snowdrifts. Other alleged pyramids are just common pyramidal mountain peaks, and alleged monster skeletons are actually the freeze-dried remains of very old seals. The conspiracy theory fundamentally collapses when forced to integrate mundane realities like logistical supply chains, the constraints of the environment, and verified satellite imagery of modern scientific bases. The deep ocean's true secrets are scientific, not espionage-related.
All right, stuffers, here's my personal take, filtering the woo-woo through a scientific and logistical lens. I'm an investigative journalist, and I'm paid to follow the money, the logistics, and the physics. The secret Nazi Antarctic base theory, as juicy as it sounds, fails on all 3 points, but the absolute definitive killer is physics. The greatest, most glaring flaw in the secret base theory is the energy requirement. If you want a vast, heated, and technologically advanced underground complex deep in Groningen, capable of sheltering hundreds of people, machining advanced aircraft, and testing revolutionary technology, you need an incomprehensible amount of continuous power. We're talking nuclear power plant level. The theory suggests this energy comes from geothermal sources, but here's the fact. Groningen is scientifically documented as being particularly geothermally quiet. There are no known accessible deep heat sources to run a major industrial operation. Secondly, consider the acoustic signature. If a base involved deep underground drilling, massive internal machinery, ventilation systems, and critically, the continuous movement and maintenance of submarines or aircraft, it would generate non-natural, high-amplitude acoustic signatures. For 80 years, military and scientific hydrophones, the same networks that detected the Bloop, have been listening to the deep ocean basin. An 80-year-long construction and operations program involving U-boats requires constant, powerful, and unique sound emissions that are detectable thousands of kilometers away. You can't be both technologically advanced and acoustically invisible. Finally, there's the logistical resource constraint. Every single supply, fuel, Food, specialized parts, medical supplies would need to be transported. The sheer volume of material needed to sustain hundreds of people and operate industrial machinery for decades requires vast, regular, and highly visible infrastructure. Massive ships, icebreakers, and aircraft landing strips. The movement of this material would be impossible to hide from the scientific stations that have operated in New Schwabenland since the 1950s. The theories require us to believe in perfect physics-defying human secrecy, maintained across multiple hostile continents for 8 decades. The complexity of the real deep sea, from gelatinous snailfish defying 11 kilometers of pressure to the simultaneous fire and ice of hybrid geological vents, is infinitely more complex and genuinely fascinating than a poorly constructed conspiracy theory. The theories ask us to ignore physics and history. I'd rather study the carnivorous bivalve. It's more plausible. Stuffers, hit that like button if your brain's already spiraling trying to figure out how they'd hide a nuclear reactor in the ice.
The most immediate and terrifying threat to the deep sea is not a mythical monster or a classified base. It is us. We stand at the precipice of a new frontier, driven by resource scarcity. The rise in global demand for critical minerals, cobalt, manganese, nickel, and others is driven largely by the green transition, particularly the needs of electric vehicles, EVs, and renewable energy systems like wind turbines. Since terrestrial sources face mounting geopolitical, environmental, and ethical constraints, undersea deposits are now viewed as essential alternatives. This is the new deep rush. These resources are concentrated in some of the most fragile deep-sea ecosystems. They include polymetallic sulfides found around hydrothermal vents and cobalt-rich crusts on the flanks of seamounts. These habitats often contain unique assemblages of marine species, and many are already recognized as vulnerable marine ecosystems, or VMEs. The race to map and claim these resources is intense. The International Seabed Authority, the ISA, the body charged with regulating activities beyond national continental shelves, has already issued 27 contracts for mineral exploration. These contracts encompass a massive area, more than 1.4 million square kilometers. Meanwhile, the rules for commercial mining are still under development, meaning exploitation is rapidly outpacing regulation. The environmental risks are immense. The extraction technologies remain largely unproven at large scales and pose 3 major threats. First, biodiversity loss, destroying VMEs that often support highly endemic life forms. Second, the creation of vast sediment plumes, which can spread for kilometers, smothering filter feeders and altering water chemistry over wide areas. Third, the potential to alter deep oceanic carbon cycles by disturbing accumulated carbon at the base of trenches. This resource pursuit presents a critical sustainability paradox. We are attempting to solve the terrestrial climate crisis by potentially compromising the deepest, least understood, and most fragile part of the planet. Scientists emphasize that given the vast scientific uncertainties and knowledge gaps, a precautionary and integrated approach is essential to ensure that securing critical minerals does not compromise long-term sustainability objectives or marine ecosystem health. The uncomfortable realization is that the pace of resource exploitation is dangerously outpacing the pace of scientific understanding. We are authorizing the potential destruction of millions of square kilometers of habitat before we have even finished cataloging the life that lives there, as demonstrated by the hundreds of new species being discovered every year.
We started this journey fearing the known unknown.
the Kraken, the ghosts of the Cold War. We ended it confronting the complexities of the newly known. The fire and ice geology, the carnivorous popcorn-shaped isopods, and the uncomfortable ethical questions surrounding resource extraction. The deep sea is a humbling place. It proved that the sound we thought was a monster was just a planetary process, a gigantic icequake thousands of miles away. It showed us that life doesn't need the sun to thrive. It confirmed that the human instinct to hide secrets in massive bases is far less successful than evolution's ability to adapt to crushing pressure. The ocean forces us to confront the limits of human knowledge and control. We map the ocean floor not just to find resources, but to understand the planet we inhabit, acknowledging how little we truly know. To realize that we are just now cataloging fundamental geological systems and hundreds of endemic species means we are scientifically still at the starting line. If you learned one thing that blew your mind, smash the like button and subscribe. We need your help to keep exploring these deep dives. Here's my final thought, something I often reflect on as a Christian, looking at these impossibly complex systems. The Hadal zone is a testament to complexity, life thriving in utter darkness and under crushing pressure, existing far beyond our immediate sight or comprehension. It's a reminder that true wonder often exists where we cannot see it, demanding awe and respect. As the Bible says, it is a reminder that there are systems, processes, and life forms operating at a scale and depth that defy easy understanding, which encourages humility in the face of creation. Ecclesiastes chapter 11, verse 5 says, "As you do not know the path of the wind, or how the body is formed in the mother's womb, so you cannot understand the work of God, the maker of all things." The final frontier isn't space, it's the deep ocean. Let's make sure we explore it with wonder before we exploit it with greed. Okay, thanks for watching. Peace out. Goodbye, guys.